All right, this is the Algebra 1 new Unit 6 review video. I'm going to go over the questions from the study guide. The study guide has been modeled on the questions that appear on the test. So these are the types of questions that you will see on the test. So you need to know how to do them. First topic here, I've given you a visual aid for knowing those three categories. Consistent independent systems have one solution. They intersect at one point. Consistent dependent have infinite solutions and represent the same line. And inconsistent are ones that have no solution. In other words, they're parallel lines. So this is the information you need to know for that portion of the test. You need to know, basically, be able to look at a system of equations and know which of the three categories it falls under. So that's kind of the first thing. The next thing is you basically need to be able to describe, or not describe, but like identify and find the solutions to systems of linear equations. So let me jump over here and we will work on these right here. So basically what you need to be able to do is you need to be able to find the solution to a system of linear equations. Now, in order to find the system or the graph of these need to be converted into y equals mx plus b form. So let me just get this. Actually, let me start over here real quick. So 3x plus 3y equals 15. And our other equation is 2x minus y equals 7. So remember, we have two basic steps when we are doing this. We need to move the x and then divide the y. So moving x means I'm going to subtract 3x from both sides here, leaving me with 3y equals negative 3x plus 15. Then I'm going to divide both sides by 3, which means I divide each item by 3. And then I get y equals, this is going to become negative 1x because the 3's are going to cancel, but the negative will still be there, plus 5 because 15 divided by 3 is 5. So there's my first equation, negative 1x plus 5. On the other side, I subtract 2x from both sides. That cancels, leaving me with negative y equals negative 2x plus 7. And then I divide both sides by negative 1 to get rid of the negative on the y. That cancels, giving me y equals, those are also going to cancel, 2x minus 7. If you need to work out each portion individually by doing like 7 divided by negative 1, that's fine as well. So now I need to basically graph these two and find where they intersect. So we're going to go over to our graphing calculator and we'll type them in. Y equals negative 1x plus 5. Make sure I got that right. And then y equals 2x plus 7. Oh, minus 7. Sorry about that. There we go. And so when we look at where they intersect, that is the piece of information that we need. The solution is 4, 1. So that's the main thing that you're going to be doing. So you're going to be putting them in graphable form and then finding out where they intersect. That's what it's talking about right here and right here. Graphing, identifying the correct graph, and finding the solution. Additionally, it says we need to fill in a table of values. When I say that, it just means that you need to be able to look at these graphs and find, like if it said, what does it equal at 5? You need to be able to go to 5 and see that it's 5, 3. Like you can see I'm dragging here. So basically just generally asking questions about different spots on the graph. That's 5, 3. This is 1, 4. Down here we have 1, negative 5. So being able to identify the different points on the graph is another kind of important concept. All right, so let's keep going and we'll do this next one here. We need to, again, convert these into y equals mx plus b. So we have 2x plus y equals 4 and 3x minus 2y equals negative 1. So in order to solve these, move the x. Y equals negative 2x plus 4. That one's already done for us. We don't have to divide by the y because it's already just one y. Then on the other side, we subtract 3x from both sides. Again, once you do this enough, it becomes pretty kind of second nature. Now we're going to divide both sides by negative 2. So that's going to cancel out, giving me y equals, okay, these negatives will cancel, but it'll be 3 over 2x. And then these will cancel as well, plus 1/2. So now we have our two graphs. So we go over to our graphing system and we put these in. We have negative 2x plus 4 and 3 over 2x plus 1/2. Let's make sure I got that typed in right. Negative 2x plus 4 and 3 over 2x plus 1/2. Get that all typed in, and we see they intersect at the point 1, 2. So that would be the solution for number 2. Number 3 is already set up for us, so we don't really have to do anything except graph these. So we'll go in, 2x plus 9, and y equals 3 is the other one. So notice this one doesn't have an mx plus b form, it's just y equals 3. So we graph that, and we find the intersection point right there is negative 3, 3. And that is it. So when it's already in y equals form, you don't really have to do any of this other work, but I want you to see that. We're going to do some more examples anyway while we're at it. So here's another one that's already set up for you. So let's go ahead and type this in, y equals 2x minus 9, and y equals x minus 3. Okay, we see they cross at the point 6, 3. Again, not much else to do there. It's already set up for you. You just graph and find the intersection point. Now, number 5 begins inequalities. You see there's not equal signs here. There's inequality symbols, but you can still type those on the calculator. So we're going to do y is greater than negative 3x plus 5. So let's go ahead and get that set up here. Y is said greater than. So we'll use this symbol here, greater than negative 3x plus 5. Okay, and you see the shading there. And then y is less than x plus 1. Y is less than x plus 1. So we see the shading intersects here. So if I was looking at the graph, I would want to find one where it's shaded. Both sections of shading are overlapping in this area of the graph over here. And then we see that the intersection point, if they ask, is 1, 2. So I'm just going to write here, intersection, but look at shading. Okay, so make sure also. So make sure you're understanding, you're kind of like thinking about it in terms of like, if I have this line is shaded here and this line is shaded here, then my solution would be in this section right here where it's shaded both. So that's what you have to be looking for. All right, one more example. I was going to go ahead and do one where we do adding them just so you could see another example of that. If you remember that we learned a few different ways of solving, but this one can be solved by doing combination. I can add these two together and that will cancel out, leaving me with 7x equals 14. Divide by 2 on both sides. X, or not by 2. Divide by 7 on both sides, leaving me x equals 2. Then I take that 2 and I plug it back into one of the equations. So we could do 5. No, actually, let's do the second one. That looks a little bit easier. 2 times 2 plus y equals 10. 4 plus y equals 10. Subtract 4 from both sides. Y equals 6. So that would be one where we solved it algebraically. But you can still solve this one using the method we used in the previous problems, putting it in y equals form and graphing it and finding that point of intersection, which in this case would be 2, 6 would be my solutions. All right, so the rest of this is going to be word problems. So I'm just going to work through these and kind of explain how to think about each one. In Carol's bedroom, there's a dresser with a TV sitting on top of it. Together, they are 5.85 feet tall, and the difference between the height of the TV and the dresser is 1.45 feet. Let the height of the TV equals x, and the height of the dresser equal y. What is the height of the TV? So this is a pretty basic system of equations. It says together they add up to 5.85 feet tall. That means that x plus y equals 5.85. Then it says the difference, which is subtraction, is, what did it say, 1.45 feet. So we're going to combine these two equations. Let me kind of fix this a little bit here. We can see here that if I add these equations up, the y's are going to cancel, leaving me with 2x on one side. And then I would add up these values, and that's going to end up being, oops. Let's go ahead and do 5.85 plus 1.45. Switch over to our scientific calculator. 5.85 plus 1.45 is 7.3. Divide both sides by 2, and we get x equals 7.3 divided by 2, which is 3.65. And it looks like I made a mistake. So I think I'll have to go fix the review, but that's how you solve it. I think this is meant to be 3.65. So that's my fault. I'll fix that in the future. But you all have multiple choice on the test, so you can always check yourself by checking that they add up to 5.85 and they have a difference of 1.45. So that is how you solve this. You set up a simple system of equations, you combine those, canceling out the y, and then solving the rest for the x value. Very similar in number 2. It says in a recent basketball game, the Rockets scored 104 points. In total, the team scored 46 field goals. Some were 2-pointers and some were 3-pointers. Let the x equal the number of 3-pointers and y equals the number of 2-pointers. So we know that in total they made x plus y 46 total field goals. Some were 2-pointers and some were 3-pointers. So there were 3 times the 3-pointers plus 2 times the 2-pointers gave them 104 points. So what you need to do then is put these in y equals mx plus b form, and then find the intersection of the two. So I'll tell you right now, the y equals form of the first equation is y equals negative x plus 46. Again, I'm not doing anything different than what we did in the previous lesson, previous stuff up above. And the y equals mx plus b form of the second one is negative 3 over 2x plus 52. So I can graph those two and find the intersection point. So negative x, let's go back to our graphing calculator. Negative x plus 46 is one of my two. Y equals negative x plus 46. And y equals negative 3 over 2 x plus 52. Now you have to zoom way out to find this solution, but you see they intersect up here, and they intersect at the point 12, 34. So x is 12 and 34 is y. So that means they made 12 3-pointers and what was it? 34 2-pointers. And so those would be my solution there because the intersection point is 12, 34. All right, 12 3-pointers and 34 2-pointers. So you can see how these relate to the problems you were doing there. And the good news is you'll have multiple choice, so you should be able to figure these out pretty easily with the multiple choice there to help you. Mr. Matthews went to the farmer's market to buy berries. First week, he bought 1 basket of strawberries and 2 baskets of blueberries, spending $9.60. So the following week, I bought 2 baskets of each and spent $12.60. How much is a basket of blueberries at the farmer's market? This, you can easily use common sense. I had bought 1 strawberry and 2 blueberry. Then I bought 2 strawberry and 2 blueberries. So the only difference is that I added a strawberry from one week to the next. And the price increased by $3. That is all you need to know, that strawberries are $3. If strawberries are $3, then I can easily use that information to find out how much it was in the first week. I had $9.60. If I do $9.60 minus $3, I end up with $6.60, which represents 2 blueberries. So then if I divide by 2, I get $3.30 for the blueberries. Sorry, I'm a little messy there. $3.30 for blueberries. So strawberries are $3 and blueberries are $3.30. Next one, adult tickets to the movies cost $8 and the kid tickets cost $6.50. What would be a possible number of kids tickets and adult tickets you could buy with $75 total? All you got to do here is multiply the prices times the number here. 3 kids times $6.50, 6 adults times 8. Add them up. 6 times 8, that's 48. 3 times 6.5 is 19.5. Add those up. 19.5 plus 48. 19.5 plus 48. 67.50. So that one is 67.50. So can I buy that with $75? Yes, I can. So we go to the next one. And we see if we can buy that one. Kids times 650. Adult times 8. Adults cost 64. 8 times 8 is 64. 650 times 4 is 26. Add those together, you get 90. So that is not going to work. That is not an answer. This one so far is good. Next one, 6 kids times 650. 5 adults times 8. Adults cost 40. Kids cost 39. Together that's 79. And that is no good. So then only one that works is answer choice A. The other two don't work. So those word problems are more or less just like problem solving. You gotta use the stuff we learned in this lesson to get those. But you can always use the multiple choice to help you. But hopefully after you do the practice test and you try these out, you'll have everything you need. So that's it for the review video. Good luck. Let me know if you need help. And reach out to me for tutoring or anything.